Astronomers have just made a groundbreaking discovery: an exoplanet orbiting Barnard's star, the closest single star to our Sun. Located just 6 light-years away, this planet, named Barnard B, is a sub-Earth world that challenges everything we thought we knew about distant planets. With its extreme conditions and unique characteristics, this discovery is set to redefine our understanding of low-mass planets. What secrets could Barnard B hold about the formation of planets? The enigmatic Barnard star, a faint red dwarf, sits just 6 light-years away from Earth, making it the closest single star to our Sun. While often overshadowed by its more famous neighbors in the Alpha Centauri system, Barnard's star is a record holder in its own right. This ancient star, estimated to be around 10 billion years old, is more than twice as old as our Sun, which makes it one of the oldest stars in our cosmic neighborhood. The star itself is significantly smaller, cooler, and dimmer than our Sun, emitting only 0.04% of the Sun's light, making it invisible to the naked eye. Despite its faintness, Barnard's star holds a key place in the hunt for exoplanets. Its unique characteristics make it an ideal candidate for astronomers seeking to understand the dynamics of planetary systems around red dwarf stars. Red dwarfs are the most common type of star in the universe, yet they are often overlooked in favor of brighter stars like our Sun. However, the discovery of a planet around Barnard's star raises intriguing questions about the potential for life around these dim stars. Could planets orbiting such stars offer the same conditions necessary for life, or do they present unique challenges that make the search for habitable planets even more complex? Barnard's star has long been the focus of astronomical study. Its relatively stable nature, compared to other red dwarfs that are prone to violent solar flares, makes it an excellent target for studying the presence of planets. The star's position, its movement through the sky, and its faintness all contribute to its attractiveness for planet hunting. Despite this, astronomers have struggled for decades to confirm whether Barnard's star hosts any planets at all, but that all changed in 2024 when a team of astronomers made an exciting breakthrough. For more than 50 years, astronomers have been searching for planets around Barnard's star, but their efforts were met with repeated setbacks. In the early years, astronomers used a technique called astrometry, which measures the tiny wobbles in a star's position caused by the gravitational pull of orbiting planets. While this technique showed promise, it didn't yield conclusive results, and the idea of planets around Barnard's star was dismissed for several decades. In the 1990s, as technology advanced, astronomers began using more sophisticated methods to detect planets. One of the most powerful tools in this search is the radial velocity method, which measures tiny shifts in the star's light spectrum caused by the gravitational pull of a planet. As a planet orbits its star, it causes the star to move in a tiny orbit as well, which in turn causes a shift in the star's light. This shift, known as the Doppler effect, can be detected even from Earth. Using this method, astronomers were able to detect small wobbles in the motion of Barnard's star. However, the radial velocity method is not without its challenges. The signal from a planet can easily be obscured by the star's own activity, such as sunspots or magnetic flares, which can produce false readings. In 2018, a breakthrough study suggested that Barnard's star might host a super-Earth, a planet with a mass larger than Earth, but smaller than the gas giants. This was an exciting possibility, as it hinted at the presence of a potentially habitable planet in our cosmic neighborhood. But despite this early excitement, subsequent studies cast doubt on the findings. A 2021 study suggested that the signal detected in 2018 might not have been caused by a planet, but instead by the star's own magnetic activity. This uncertainty persisted until a groundbreaking study in 2024 finally confirmed the presence of a planet orbiting Barnard's star, a discovery that would reshape our understanding of exoplanet formation. What techniques did astronomers use to confirm the existence of Barnard B? And what did they discover about this planet that could challenge everything we know about planetary systems? The confirmation of Barnard B. In October 2024, a team of astronomers led by González Hernández published a study that definitively confirmed the existence of a planet orbiting Barnard's star. The team used the Espresso spectrograph, an advanced instrument installed on the Very Large Telescope in Chile, to measure the tiny movements in the star's light with unprecedented accuracy. Over the course of 4 years, the team observed Barnard's star 156 times, collecting data from May 2019 to July 2023. This careful analysis allowed them to separate the signals caused by the star's own activity from those caused by an orbiting planet. The results were groundbreaking. The astronomers discovered a signal with a period of about 3.15 days, which was strong enough to suggest the presence of a planet with a minimum mass of 0.37 Earth masses. This planet, dubbed Barnard B, orbits its star at a distance of just 0.0229 AU, which places it far too close to its star to be in the habitable zone. With an equilibrium temperature of about 400 Kelvin, Barnard B is far too hot to support liquid water on its surface, which means that life as we know it is not possible there. However, the discovery of Barnard B opens the door to understanding the types of planets that could form around red dwarf stars, and how these planets could evolve over time. The planet's small size and close orbit suggest that it is likely a rocky world, although more observations are needed to confirm its exact composition. Barnard B's discovery also challenges previous theories about the types of planets that can form around red dwarf stars. In the past, it was thought that planets orbiting red dwarfs would need to be in a certain range of distances to have the right conditions for life. Barnard B's extreme orbit defies these expectations and suggests that planets with unusual orbital characteristics can still be detected and studied. While Barnard B is unlikely to support life as we know it due to its high temperatures, the discovery of this planet raises important questions about the potential for life on planets that orbit red dwarf stars. Red dwarfs are the most common type of star in the Milky Way, and many of them host planets in their habitable zones. These planets, known as Earth-like exoplanets, have the potential to support liquid water and, by extension, life. However, the conditions around red dwarfs are far from ideal. Red dwarfs are known for their violent activity, including solar flares and intense radiation bursts, which can strip away a planet's atmosphere and make it difficult for life to thrive. Barnard B's proximity to its star means that it likely experiences significant radiation and stellar flares, which could have stripped away any atmosphere it might have had, making it inhospitable. That said, Barnard B's discovery provides astronomers with an opportunity to study planets that orbit close to their stars and experience extreme conditions. By understanding how planets like Barnard B evolve and survive in such environments, scientists can refine their models for habitability and better identify which planets in the habitable zones of red dwarf stars might have the conditions necessary to support life. This knowledge is essential for future missions, such as the James Webb Space Telescope, which will be able to analyze the atmospheres of exoplanets and search for signs of life. The discovery of Barnard B also provides a new benchmark for future exoplanet research. Even if Barnard B itself is too hot for life, the techniques used to detect and study it can be applied to other exoplanets that may have more favorable conditions. As technology improves, we may discover more planets like Barnard B, planets that offer valuable insights into the formation of planetary systems and the potential for life in extreme environments. What are the implications of Barnard B's inhospitable conditions for future searches for life? What's next for Barnard B and beyond? Barnard B's discovery opens up exciting new possibilities for the study of planets in extreme conditions. But what comes next? What can we expect from future observations and research on Barnard's star and its planets? With the discovery of Barnard B, scientists now have a powerful tool for studying low-mass, close-orbiting planets around red dwarf stars. This is a whole new area of exoplanet research that could revolutionize our understanding of planetary formation and the potential for habitability. One of the next big steps is to use even more advanced instruments, such as the Extremely Large Telescope, ELT, and the James Webb Space Telescope, JWST, to study Barnard B and other exoplanets in greater detail. These telescopes will be able to analyze the atmospheres of exoplanets, measure their chemical compositions, and look for signs of habitability. By studying the atmospheres of planets like Barnard B, astronomers can learn more about how planets evolve in extreme conditions and whether there are any hidden signs of life on these distant worlds. The data gathered from Barnard B will also help astronomers refine their search for habitable planets. Understanding the environmental conditions on planets around red dwarf stars is crucial for identifying the best candidates for further study. As we continue to discover new exoplanets, the insights gained from Barnard B will provide a crucial context for understanding the potential for life elsewhere in the universe. As technology improves and more exoplanets are discovered, Barnard B will remain an important benchmark in the search for planets outside our solar system. With each new discovery, we edge closer to answering one of the biggest questions humanity has ever asked: are we alone in the universe? The discovery of Barnard B marks just the beginning of what could be a new era in the search for exoplanets. As astronomers push the boundaries of what is possible, new technologies and instruments are playing a pivotal role in uncovering more of these distant worlds. The two most prominent tools on the horizon for planetary exploration are the Extremely Large Telescope and the James Webb Space Telescope. Both of these state-of-the-art instruments will revolutionize our ability to detect and study exoplanets, and they will play a crucial role in examining planets like Barnard B. The ELT, currently under construction in Chile, will be the world's largest optical telescope once it's completed. With a 39-meter primary mirror, the ELT will be capable of capturing incredibly detailed images and spectra of distant stars and planets. This capability will allow astronomers to study planets in greater detail than ever before, analyzing their composition, atmospheres, and even their potential for habitability. For planets like Barnard B, the ELT will be able to detect the faintest signs of atmosphere or geological activity that could provide insights into the planet's history and potential for life. Meanwhile, the JWST, which launched in December of 2021, is already providing a wealth of information about exoplanets. The JWST specializes in infrared observations, which allow it to peer through the clouds of dust and gas that often obscure distant planets. By analyzing the infrared light emitted by a planet, astronomers can study its temperature, atmospheric composition, and even look for signs of life. The JWST will be instrumental in examining planets like Barnard B, helping scientists determine whether conditions on these distant worlds could have supported life in the past, or if they ever could in the future. As these telescopes continue to make discoveries, they will change the way we think about planets like Barnard B. The ability to study these planets in greater detail, especially in the infrared spectrum, will open up new possibilities for understanding exoplanets that we could have only dreamed of just a few decades ago. The data from the JWST and the ELT will offer insights into the atmospheres of these planets, providing a much clearer picture of their potential for life. Could Barnard B hold secrets that we've been searching for? With these new technologies at our disposal, the answers may be closer than ever. What could we learn about Barnard B's potential for life with the help of the JWST and ELT? Keep watching to find out how these telescopes will reveal more than we ever thought possible. The search for life beyond Earth. The search for life beyond our solar system has always been one of the most fascinating pursuits in science. The discovery of a planet orbiting Barnard's star opens up new possibilities for understanding whether life could exist on worlds far from our own. While Barnard B might not be a habitable world in the traditional sense, its discovery could provide important clues about the conditions necessary for life to emerge on other planets. Barnard B's extreme conditions, with a scorching temperature of around 400 Kelvin, make it an unlikely candidate for hosting life as we know it. However, The very existence of a planet like Barnard B offers insights into the diversity of exoplanets that exist in the galaxy. Planets with varying sizes, distances from their stars, and temperatures could hold different types of environments that could foster life, environments that we might not yet fully understand. The discovery of planets in the habitable zone of their stars, where liquid water could potentially exist, is one of the key areas of focus for astronomers. While Barnard B is located far outside this zone, it still provides valuable information about the types of planets that can form around red dwarf stars. As the most common type of star in our galaxy, red dwarfs like Barnard's star are likely to have many planets in orbit around them, some of which could be in the habitable zone. These discoveries are crucial because they help astronomers identify potential candidates for life in the universe. Moreover, the development of advanced telescopes, such as the JWST, will allow scientists to directly analyze the atmospheres of distant exoplanets. By studying the chemical composition of these atmospheres, researchers can look for signs of life. For example, the presence of certain gases, like oxygen or methane, could indicate biological processes at work. With the advent of these powerful tools, we are entering an era where the possibility of discovering life on other planets is becoming more and more likely. The discovery of Barnard B also highlights the importance of studying exoplanets in detail. Even though Barnard B may not be habitable, its study can reveal how planets form, evolve, and interact with their stars. Understanding these processes is critical for identifying planets that might one day support life. And as the search for life beyond Earth continues, each discovery brings us one step closer to answering one of the most profound questions of all. Are we alone in the universe? In the grand scheme of exoplanet research, Barnard B is more than just an isolated discovery. It's part of a much larger picture. Over the past few decades, astronomers have made remarkable strides in finding planets outside our solar system. With over 5,000 exoplanets discovered so far, researchers are now able to study planets in more detail than ever before. But Barnard B's unique characteristics make it stand out among the hundreds of known exoplanets. One of the key aspects of Barnard B's significance is its proximity to our solar system. At just 6 light-years away, it is one of the closest known planets to Earth. This makes it an excellent target for further study, especially with the advancement of telescopes like the JWST and ELT. By studying Barnard B and other nearby exoplanets, scientists can learn more about the composition of planets around red dwarf stars, which are believed to be the most common type of star in the Milky Way. In addition to its proximity, Barnard B's mass and orbital characteristics make it a valuable object of study for understanding planet formation. While Barnard B may not be a perfect analogue for Earth, its discovery contributes to our understanding of how planets of various sizes and orbits form. Researchers can use this information to refine their models of planetary evolution and gain a deeper understanding of how different conditions lead to the development of planets with a wide range of features. Furthermore, Barnard B's discovery highlights the growing importance of collaboration in the field of exoplanet research. International teams of scientists from around the world are working together to analyze data from multiple telescopes and spacecraft. This global effort is accelerating our ability to find and study exoplanets, and it's opening new possibilities for future missions that could provide even more detailed information about distant worlds. As we continue to explore the cosmos, the study of exoplanets like Barnard B will play a critical role in advancing our knowledge of the universe. The more we learn about these distant worlds, the closer we get to answering the fundamental questions about the origins of planets and life itself. How does Barnard B fit into the broader context of exoplanet research? Discover how this new planet is helping to reshape our understanding of the universe. The implications of Barnard B's discovery for future space missions. As we learn more about Barnard B and other exoplanets, the implications for future space missions are profound. For decades, humanity has dreamed of sending spacecraft to explore distant stars and planets. The discovery of Barnard B could play a pivotal role in shaping the future of space exploration by providing valuable targets for future missions. One of the key factors that will influence future space missions is the advancement of propulsion technologies. While current spacecraft are limited by the capabilities of chemical propulsion, new technologies, such as ion drives and nuclear propulsion, could one day make it possible to send probes to exoplanets like Barnard B. These advanced propulsion systems would allow spacecraft to travel much faster than current technology allows, making missions to distant stars and planets more feasible. In addition to propulsion, future space missions will also require the development of new tools and instruments capable of studying exoplanets up close. Space telescopes like the JWST and the ELT are already providing valuable data about distant worlds, but sending a probe to directly study an exoplanet would offer an entirely new level of insight. Future missions could carry instruments designed to analyze the atmospheres, surfaces, and magnetic fields of exoplanets, providing a more complete picture of these distant worlds. Moreover, the discovery of Barnard B could pave the way for international collaborations on future space missions. As space agencies around the world look to expand their exploration of exoplanets, working together on joint missions could maximize the chances of success. The potential for cooperation between agencies like NASA, the European Space Agency, and private companies could open up new possibilities for missions that would have been impossible just a few years ago. Barnard B's discovery is also a reminder that space exploration is not just about reaching distant planets, it's about understanding the conditions that make life possible. By studying exoplanets like Barnard B, scientists can gain a better understanding of the factors that contribute to habitability. These findings will guide future missions to planets that are more likely to support life, bringing us one step closer to finding a second Earth. The discovery of Barnard B represents a major milestone in the quest to find habitable planets beyond our solar system. However, it is just one example of the many exciting discoveries yet to come. As technology continues to advance, the future of exoplanet discovery is looking brighter than ever. New tools, more powerful telescopes, and advanced detection methods will allow us to find even smaller and more distant planets, providing new insights into the possibilities for life elsewhere in the universe. In the coming years, the James Webb Space Telescope will continue to play a crucial role in the discovery and study of exoplanets. With its ability to observe in the infrared spectrum, the JWST will be able to detect planets that are too faint to be seen with optical telescopes. By analyzing the atmospheres of these distant worlds, scientists will be able to identify the chemical signatures of life, giving us our first glimpse into the potential for habitability beyond Earth. At the same time, the development of new ground-based observatories, like the Extremely Large Telescope, will enable us to study exoplanets in greater detail than ever before. With a mirror over 39 meters wide, the ELT will be able to capture incredibly detailed images of distant planets, providing valuable data on their atmospheres, surfaces, and potential for supporting life. The future of exoplanet discovery is not limited to the study of planets in our own galaxy. With the advent of interstellar probes, humanity may one day be able to send spacecraft to other star systems, exploring planets up close and personal. While these missions are still far off, the discovery of planets like Barnard B is laying the groundwork for future generations of explorers. As we continue to uncover new exoplanets, the implications for our understanding of the universe are enormous. Each discovery brings us one step closer to answering the age-old question: are we alone in the cosmos? With the tools we have at our disposal and the technology on the horizon, the future of exoplanet discovery is incredibly exciting. What's next in the search for exoplanets? Find out how new technology is revolutionizing the hunt for life beyond our solar system, Barnard B, and the impact on search for Earth-like planets. As we journey through space and continue to uncover new exoplanets, one of the most profound questions we face is whether there are planets that could support life as we know it. Barnard B, while not a habitable planet itself, plays a pivotal role in how we think about the possibility of Earth-like planets in distant solar systems. Its proximity, composition, and the methods used to discover it have opened a new chapter in the search for exoplanets that could resemble Earth. The planet's close orbit around Barnard's star, a red dwarf, offers astronomers a rare opportunity to study how planets form around such stars. Red dwarfs are the most abundant type of star in our galaxy, accounting for around 75% of all stars. Despite their prevalence, little is known about the conditions of planets that orbit these stars, as most exoplanet discoveries have focused on stars similar to our Sun. Barnard B, therefore, is offering researchers a window into the mysteries of planets around red dwarfs. While Barnard B is far from habitable due to its extreme temperatures and close proximity to its host star, its discovery is important for understanding the diversity of planets in the universe. The planet's size, composition, and orbit could provide vital clues to the formation of rocky planets that may exist in the habitable zones of other red dwarfs. The study of Barnard B and other planets like it will allow scientists to refine their models of planetary formation and assess the potential for life elsewhere. What is most exciting, however, is that Barnard B may not be the only planet in this system. As astronomers continue to analyze the data gathered from the espresso spectrograph and other instruments, it's possible that they will uncover additional planets orbiting Barnard's star. Some of these planets may be located in the habitable zone, where conditions could be more favorable for life. By studying Barnard B and its neighboring planets, scientists are moving closer to identifying Earth-like worlds that could one day be suitable for human exploration. Barnard B is also a testament to the incredible advances in technology and methodology that have made these discoveries possible. The improvements in instruments like the espresso spectrograph and the upcoming capabilities of the James Webb Space Telescope will enable us to explore even more distant exoplanets with greater accuracy. These tools are paving the way for future discoveries that could bring us closer to finding a second Earth. As we continue to explore the stars, the Barnard star system presents an intriguing possibility for future human exploration. While Barnard B itself may not be a candidate for habitation due to its extreme temperature and close orbit to its star, the study of this system could serve as a stepping stone toward deeper exploration of other, more hospitable worlds. With the rapid advancements in space travel technology, we may one day find ourselves traveling to these distant stars, uncovering the mysteries of planets like Barnard B and the other potential worlds that orbit red dwarf stars. One of the most exciting aspects of the Barnard star system is its proximity to our own. At just 6 light-years away, Barnard's star is one of the closest stars to Earth. This makes it an excellent target for future space missions. While current space travel technology is not capable of sending humans to Barnard's star, advancements in propulsion systems, such as ion drives and nuclear fusion propulsion, could make interstellar travel a reality in the distant future. These advanced propulsion methods would allow spacecraft to travel much faster than current chemical rockets, bringing us closer to these distant star systems. Human exploration of exoplanets is still many years, if not decades, away. However, the data collected from Barnard B and similar exoplanets will be critical in preparing for such missions. Studying the atmospheres, surfaces, and conditions of these planets will provide valuable information on what it would take to survive on these worlds. If a planet within the habitable zone of Barnard's star, or another red dwarf, is discovered in the future, it could be a prime candidate for future human colonization. The technology required to send humans to these planets, coupled with the knowledge gained from previous missions, could make the dream of interstellar exploration a reality. Moreover, the search for life on other planets continues to drive the push for human space exploration. As we study planets like Barnard B, we not only learn about the conditions necessary for life, but also the challenges of surviving on planets with extreme environments. This knowledge will be essential for future missions aimed at establishing human colonies on other worlds. Barnard B, with its extreme conditions, could serve as a crucial test case for scientists to understand the challenges of colonizing planets in inhospitable environments. The Barnard star system is also a reminder of the vastness of the universe and our place in it. While we may be far from sending humans to planets like Barnard B, the discovery of such exoplanets brings us one step closer to understanding the incredible diversity of worlds that exist beyond our own solar system. As our technology continues to advance, the dream of exploring distant stars may become a reality, and Barnard B could be one of the first planets we study in great detail. As we continue to advance our technology, the search for Earth-like planets is closer than ever. Thanks for watching, and make sure to comment and share your thoughts on what this discovery means for the future of space exploration.